Alright, so what I've done for you, I've made this video where I got PLC meetings today, and I want to make sure you're getting the same things I've been given to the other biology classes today. So Miss Hall has this video to play for you guys, and listen to me carefully. You need to put this in your notes. Am I here to watch you to see if you put it in your notes? No. Is Miss Hall going to make sure you put it in your notes? Probably not. But what am I saying? You need it in your notes. You need an understanding of this. I want to make sure you understand what's going on. Along with that, Miss Hall has probably already gave you, or if she hasn't, she's going to give you
There's a right-hand side to the gym place.
New notes. Hold on, let me turn that down so it won't kill us. But she's probably gave you the new printouts, and the reason I'm giving you new printouts is so many classes of the ones I'm looking at, everyone has done. We're so far off that instead of using all the eraser from your pencil, I figured it was just better just give you a new sheet. So I would advise taking it using the new sheet, because you're going to see here in a second where we're so far off. I want to show you what I'm talking about, so I actually want to go through situation number 1 and talk about scenario number 1. So this is what's going on. So it's like we got a cell in here, and this is what we're looking at. So there's the cell, and around the cell there's environments. So we're looking and seeing by the situation of what the person has done, and eventually the environment that's going to be around the cell. So I'm going to do situation 1, and I know exactly what you're going to do. I've been at this for a little bit. I know exactly what you're going to do. You're going to write down exactly what I write down and put for your first answer. That's fine. I don't care. That's perfectly fine. But the key is you need to understand why my answer is my answer. You need to understand this is my expectation for every one of your answers. You need to explain things. And we are still struggling with explaining things. And another thing with this is, and I'm going to hit it out, I've got on other kids today for doing this. This is not an assignment that you should be having one person do and you copy. You need to know the information, you need to understand it. Have a conversation with them. They can help you, but it doesn't mean that you copy it down. Like, I know you're going to copy down what I'm about to say on situation 1. That's fine. But what you need to do is have an understanding of it, because when you get to situation 2, 3, 4, 5, and 6, they're different. You need to understand the science behind this. So situation 1 says a person decided that they would go to McDonald's and consume an outstanding 10 McDoubles with extra cheese. For their beverage, they have consumed 3 Dr. Peppers and 0 waters. So what that means in translation is that we have a cell, and inside the cell there's stuff in the cell that's being used. Proteins, there's lipids, there's amino acids, there's different things in there. There's glucose or sugars. We're looking at all this. There are what we call solutes. All those things I just listed off as macromolecules, they're solutes. And they're inside the cell here. Now, what is taking place is whoever has done this has ate tons of food. So when they've ate all this food, what they have done, eating all of this food, is they have taken a ton of those macromolecules, and their digestive system is breaking it down, putting it in their bloodstream, surrounding their cells with it. So this is what it looks like. So that's what the solutes around the cell looks like. So we have solutes in the cell, we have solutes out of the cell. And what we're looking at is the very first thing I ask you to do on this is tell me the type of environment. So you have to deduce from the situation what they've done. In this case, this person ate tons of food, added no water to it. I know what you're going to say, Dr. Pepper has water in it. It has tons of sugar, tons of additives. They've added tons of solutes around the cell. So when we look at this, the thing that we're going to say first is we want to know the environment. And the environment we have created, in this case, is one that we would label as hypertonic. Now, so far, everybody's done really good with picking the type of environment out. How do I know this is a hypertonic environment? It's based off of the concentration. On the outside is a high concentration. On the inside of the cell is a low concentration. How in the world do I determine that? I have tons of more solutes on the outside of the cell than I do on the inside of the cell. By the way, let me add this to you. I'm not expecting a picture on these answer sheets. You can put one if you want. I'm not expecting that. This is here so that you can see and get a representation of what I'm talking about. So in this case, I have a high concentration of solutes on the outside, low concentration of solutes on the inside, which then brings us to how these things will diffuse. So the first one we're going to talk about is we're going to look at and talk about is the solutes diffusing. The key to this is making sure you answer hows and whys. I know you just rolled your eyes, that's okay. At least it's sticking. I want to make sure we get hows and whys here. You've got to know the hows and whys. That's how we explain stuff in science. I'm trying to get you to explain. That's why in parentheses I say explain the how and why. It's not as simple as looking and saying the solutes that, well, it's going to go high to low, so it's going to go into the cell. That's great. That's not what I'm asking you to do. I'm asking you to explain what it's going to do. So you have to add that in as the explanation, but that's not an explanation. That's telling me what's going to happen. I'm taking you deeper. This is a deeper level of thinking here. So the solutes, how I would answer this is looking at it and saying that the solutes will diffuse into the cell. Because, so I'm going to a because. This is the why. The solutes are going to go into the cell because of the high concentration on the outside of the cell. Solutes diffuse from high to low concentration. So we're going to go from a high to low concentration. This is how the solutes are going to diffuse. Perfect. Perfectly good. Along with this, that's the how. That's the why. Now we need to hit the how. How are the solutes doing this? The solutes, I'm just going to say they do this by using channel and carrier proteins. because they can't freely diffuse across the membrane. At this point, you should start looking and say, I just covered the how, I just covered the why. They're both there. You have to have them both. So solutes diffuse. For solutes diffusion, the solutes will diffuse into the cell because of the high concentration on the outside of the cell. Solutes diffuse from high to low concentrations. They do this by using channel and carrier proteins because they can't freely diffuse across the plasma membrane. Now, that's one piece. That's just the solutes. Now we got to get to the water. So we get to the water, that's osmosis. What you need to remember with osmosis, all this is a diffusion of water. You have to answer the how and why here as well. So we're going to look at the diffusion of the water across the plasma membrane. In this case, water will push out of the cell to dilute the higher concentration. Water diffuses from low to high concentration. So this is the way to look at it. The water is what things are dissolved in. So if we push more water in, it lowers the concentration. And what that's called is called diluting. So water will push out of the cell to dilute the higher concentration. Water diffuses from low to high concentration freely through the plasma membrane. It does this. Here comes the why. To reach equilibrium. This is what we're doing it for. We're trying to get to equilibrium. We're trying to get to homeostasis. This right here is the expectation I have for you guys when it comes to you answering these questions of these situations and scenarios. And again, I want to stress to you, don't just copy something. I know that you're trying to copy this word for word right now. That's why I'm standing out of the way so that you can actually see it, so that you got a shot at trying to get it down. I am telling you, you need to understand what this is. You need to understand, we determine the environment based off where the concentration is. High concentration outside is hypertonic. High concentration inside, hypotonic. Concentration the same on the inside and the outside, isotonic. Then the solutes will always diffuse from high to low concentrations, and then water will always diffuse from low to high concentrations. So want to make sure you get this, make sure you understand this, you can work through this. There are different types. I'm telling you, not every one of them out there is hypertonic. I have hypertonic, hypotonic, and isotonic. And I want to add this. You should need more time than just today to finish this. But if you feel you're done with this and you finish this, turn it into Miss Hall. She'll have it, and I'll keep it, and I'll grade it. But this is not something that you're just going to do. I'm telling you, this should take a lot more time. This is the expectation. This is the level I want your answers on. I'm sorry I can't be in class today to help you out. I should be back in tomorrow to answer any questions or anything. So have a great, wonderful rest of your day, and Miss Hall will be taking it from here.